In a previous video, I showed you how you can reset the position of your object whenever you press the mouse. Specifically, here we're moving to the right because we're adding to the x-coordinate every loop. And then I'm saying if the mouse is being pressed, then reset the coordinates back to 400, 400. And it looks like this when we run it. Here the mouse moves, the circle moves, and then I click, and every time I click, it resets to the center. So how could I get it to reset to the center when the circle hits the edge of the screen? What I need to do is I need to change the if statement, because the if statement is like a question. It's saying, when should we do this action? So right now, this action is resetting the ball to the middle, and when I'm doing it is when mouse pressed is true. But I want to say something like when the ball is off the right side of the screen. So the question is, how can I say this in code? Remember what the coordinates look like. If the ball is off the right-hand side of the screen, that means that the x-coordinate is going to be very large. Here in this picture, my x-coordinate only goes up to 600, but in our windows, the x-coordinate goes up to 800. So if the circle is off the right-hand side of the screen, that means that the coordinate is larger than 800. So that's the test that we'll set up. To test the horizontal position of the ball, we have to test if x is greater than 800. And we can see what that looks like now. When the ball reaches the edge of the screen, it naturally resets. What would happen if we made this smaller than 800? What if we made this 600? Let's run it and see. You see that the ball seems to reset its position whenever it hits about this point on the screen. And if you're guessing that this point on the screen has an x-coordinate of 600, then you're thinking right about this code. Because we're saying whenever the x-coordinate is bigger than 600, reset it back to 400. We can test for sure by making a line there. So let's draw a line from an x-coordinate of 600 and a y-coordinate of 0 to an x-coordinate of 600 and a y-coordinate of 800. So this is going to be a vertical line that goes from the top of the screen at 0 to the bottom of the screen at 800. So now we can see the boundary, and you can see that whenever the circle hits the boundary, that's when it resets. What if we didn't want to reset the position to the middle of the screen? What if we wanted to reset the position to the left-hand side of the screen so that it looks like the ball hits the wall and then enters again from the left-hand side? What do you think we'd have to change? We're not changing the question for when do we perform an action. We still want to do something whenever the circle hits the boundary. Instead, we want to change where it resets to. Right now it's resetting to 400, 400, but we want it to reset to the left-hand side of the screen. Looking at the coordinates, the left-hand side of the screen has an x-coordinate of 0. So let's reset the x-coordinate to be 0 and take a look and see what it looks like. Now we hit the boundary and we enter at the left-hand side of the screen. Now let's get rid of the line and let's reset it to the original boundary that it was going to detect. So here I'm detecting, is it off the right-hand side of the screen? And if it is, let's re-enter on the left-hand side of the screen. And I don't want to change the y values at all. So now we've got a situation where it hits the right-hand side of the screen and it comes back in the left-hand side of the screen. That's called screen wrapping, because it's like I'm wrapping around the edges of my window. To make this effect a little bit more obvious, let's reset the y-coordinate to be 0, and let's add a slow downward movement. And let's speed up my right-hand movement. Okay, so you'll see, as I hit the right-hand side, it re-enters the left-hand side, but my vertical motion hasn't changed at all. I'm still going down very slowly. What if we wanted to add another screen wrap when it hits the bottom? So in other words, when the circle goes off the bottom of the screen, it re-enters at the top of the screen. Think about how you would do that with a similar if statement. And remember the structure of why this makes sense. This part was saying if circle is off right side of screen, then reset X to left side of screen. So for your if statement, we want something like, if the circle is off the bottom of the screen, reset it to the top of the screen. Go ahead and pause the video and guess how you do it. Okay, so if I'm testing if the circle is off the bottom of the screen, that's its vertical position. So I need to test the y coordinate. You might think that you'd want to test if y is less than 0, because you're still thinking about the coordinate system that you'd use in math class. But remember the coordinate system. It looks like this. So off the bottom of the screen means that you have a very large y coordinate. Oh, I'm just noticing 500, 500 here. That doesn't make sense. Okay, well, I'll change that later. So the y coordinate, so if the y coordinate at the bottom of your screen is 800 and you want to test, are you below the bottom of the screen, you're testing if the y coordinate is larger than 800. So if y is larger than 800, then I want to reset y back to be 0, because 0 is the top of the screen. So now when we run it, you'll see that when the circle reaches the bottom of the screen, it's going to reset to the top. If you wanted to add tests for all 4 walls, it would look something like this. Testing to see if you've hit the right side of the screen is the x-coordinate larger than 800. Testing the left side of the screen would be x-coordinate smaller than 0, because 0 is the coordinate at the left-hand side of the screen. Testing the bottom edge would be if y is larger than 800. So testing if you're hitting the top edge would be testing if y is smaller than 0, because 0 is at the top. And in each case, I'm resetting the coordinate to be the opposite edge of the window. When we're screen wrapping, as long as you're only moving in one direction, you're only ever going to hit 2 of the edges, and you're not going to hit the other 2. But later on, when we have the object bounce, then you do need tests for all 4 edges. So it's nice to kind of set up what the structure looks like now. As a final note, you might be wondering, why don't we test to see if the x-coordinate is equal to 800? Because isn't that like asking, is the x-coordinate equal to the right-hand side of the screen? Remember how movement works. Every single time we go through the draw method, we're adding 5 or some other number to the x-coordinate. So that means that even though it looks like the motion is smooth and continuous, actually the coordinates are jumping every single frame. So what happens if your circle is at 791 and 400? In the next frame, it's going to jump 5 pixels to the right. So it'll be approximately here. And now it's at a coordinate of 796, 400. And then in the very next frame, it's going to jump 5 more pixels to the right. And now it's gone past the edge of the screen, but the coordinate is 801, 400. So we've actually jumped over top of the boundary we were checking. And if you were checking to see if x equals 800, the answer is at no time was our x-coordinate equal to 800 because we jumped over it. So that's why we always test using inequalities, because we want to see if the x-coordinate is past the boundary, because we might not be exactly equal to the boundary depending on how fast we're moving.